Okay, in this section, we're going to talk about arrays and array list. And this topic is probably the most commonly used objects in Java. And the way that you think about it is whenever you're looking at any kind of application or doing some kind of processing, you're either processing an array of orders, you're looking at an array of pictures, or you are looking at an array of numbers. So there's a lot of things that are done in programming that have a lot to do with arrays. Okay. So there's a lot of other topics that comes along with arrays. There's searches, parallel arrays, two-dimensional arrays, and so forth. So we're going to try to get into all of this. So arrays are a way that we can hold basically a list or basically an array or list of values. And primitive variables are designed to hold only one variable at a time. But if we use an array, we can hold a collection of those similar kinds of data types, and we can use an index to get into each one of those values. And then we can store that any kind of data of that certain kind of data type, but we can only stay with one data type at a time within one array. And in many cases, an array is a list of data elements. So this is in the case here of using array to basically represent an array of numbers. So here we have a variable numbers, and it's going to contain basically a collection of integers or ints. Here you can see that we have 6 of them, and they are referenced by a variable called numbers. And in the case of when we're dealing with an array of primitive types, in this case, int, which is a Java primitive, the Java virtual machine will set the elements of that array to 0. And in the lab of this week, you'll see a small little demo of how we initialize certain arrays. And here we can say we can allocate or declare or initialize an array of ints pointed to with a variable called numbers, and we want to initialize it to with a set of 6 ints or 6 integers. Okay, and then we can have arrays of different types as well. We can have floats, chars, longs, doubles, and so forth. And we can actually use objects as well. But for now, we're just talking about primitives. So the array size must be a non-negative number. It can be 0. So it can be 0, 1, 2, so forth, up to some manageable number. And once you allocate a certain size of the array, it cannot change. The only way that you can actually put more things into the array that let's say this one is 6. Once you try to put something in it that exceeds 6, it won't fit. What you have to do, you actually have to delete it or create another array that is larger than 6. So here is a way that we access the actual elements within the array. So the array is accessed by the reference name, in this case numbers, and then we use this square brackets and we put the index into it, and it will then let you access the individual values in it. In this case, we're assigning a value of 20 into the first element inside of the numbers array. And here we say things like number sub 0. And then the actual individual elements can be treated like any other kind of variables. You can do basically any kind of Java programming with it, as long as you are dealing with it at the data type level. So there's things that need to be very kept in mind with arrays, which is the bounds checking. So the bounds checking is that when you allocate or initialize an array of a value called an array called values, and you initialize it to 10 elements, that you cannot go you cannot exceed or try to get to elements outside of what it actually exists. So you have to access it through indexes 0 through 9, and all the arrays are always zero-based indexing. And so when we use a for loop, we can use these typical one-letter variable names, ijk, as sort of like a counter or index into the array. And then there is a special attribute on the variable, like say temperatures, on any kind of array, let's say temperatures or numbers that we saw before. If you wanted to find out how many elements are in the array, there is a special attribute called length, and that length will tell you how many elements are inside of that array. And then this is a typical way of using that length attribute to do like a for loop to get to access all the elements or accessing the elements inside of the array. And then there's the most common problem that is often seen in Java programs is the uh, array index out of bound exception. And that's when you basically try to access an element in the array that doesn't exist. If you try to, let's say, in this array of int numbers, if you try to access something that was at int 100 or 101, it will give you, and the code actually ran, you would get this kind of exception. And when you initialize the array, there's times when you can initialize it using this kind of notation. You use these curly brackets. This is often used when the number of elements that you're initializing with is sort of a small number. I mean, a small set of values. You don't really typically want to do this when your set of values you're initializing with is very large, like maybe over 50 or 100 elements. That just makes it very impractical. And here you can see that we're initializing each element by the sequence that they are used here. So 31 goes into the zero-based element, 28 goes into the one-based, one indexed element, and so forth. And so there's other ways that you can do the array declaration. You can use the brackets on the data type side, or you can use the brackets on the variable name side. They're basically interchangeable, but the first style is typically the most common because you are keeping the data type together versus the data type being split between the left and right side of the variable. There are ways to do multiple array declaration, but it's typically not a good practice to do so, but this is allowed in the Java language. And there's also ways to do that similar one above, but putting the brackets on the variable name side versus on the data type name side. And again, best practice is to really declare each variable on a separate line and not to combine them all together on a single line. Uh, so when you access the array elements on the array content, you can access them just like any variable and then do processing with it in just like any other way. So if your data element in hours is either an int or a double here, that it will, you do the indexing into that array, and then you're doing some kind of, let's say, paycheck processing. And this is a numerical data type, and this is also a numerical, probably a double or float. And then you can set it to some compatible data type here. And then there are, of course, we've seen the initialization, and then this is the pre-incrementation or post-incrementation operation. So you can use the data elements like in any kind of conditional operations. You can use them in the if then else, or you can use them directly in a while loop. And there's a special kind of enhanced for loop where instead of doing a for some initialization of some, let's say the index of 0, and then uh, checking whether the index is less than length and then incrementing the index, you can just do data element, variable name, and the array name. And that would look like this one here. So here, this is the variable name for the array. This is the data type of the elements in the array. And then this would be the variable within the for loop for getting to that each individual element within this enhanced for loop. So again, the special attribute of length can be used for getting into the getting the number of elements inside of the array. It always starts at 0, and it's always one less than the or one less than the array length value. So you never want to make this less than and equal. You always want to keep it as less than. Here you can actually do the initialization of the array dynamically. So you can actually allocate certain number of elements. Here you're saying, I don't know how many elements I'm going to put in this array called test, but then I can initialize it and allocate a certain amount of elements to be initialized and then referenced by this variable named test. When you change the array referencing, here we are have a reference to an array called numbers. And if we do something like this, where we use that same reference number of or variable number numbers and we set it to a new initialization or set it to a different array, then this reference now gets reassigned to point to this set of data, this set of array. And then the previous one doesn't have any, this set of array, this set of integers in this array no longer has a reference to it. And eventually the automatic Java garbage collector will collect it and delete it. So when we reassign array references or array variables, so here is the case where we just talked about, where we had initialized some variable or reference called numbers, and it was pointing to an array of 10 elements or 10 integers. And then when we pointed the numbers to a different set of a different array list of int5, then basically this reference or this address of numbers points to a different array structure in memory. And then this one here no longer has anything being referenced by this. And eventually it will get deleted. Copying arrays, it's not, so you have to think about this very carefully. So if you initialize an array like this and then just point another variable of the same data type to that same array 1, it doesn't actually copy. This is actually not two separate arrays being that you have. It'll be instead like this, where you have two addresses or two variables pointing to the same array of integers. If you really do want to copy it instead, what you have to do is you first have your first array. You have to allocate the similar size or compatible size into the second reference or second variable. And then you have to copy the individual values from the source array to the destination array. And then when you pass array elements into a function method, it's just like passing any kind of data type um, into a method parameter. So here you can see that when we pass the entire reference or the entire reference of numbers into a function called show array, we're passing just the address. We're not passing the entire data structure into the function. And then what we're going to do is we can process that array just like in any other place. And so when we're comparing two arrays to see whether they're different or the same, we can't use this equal equal operator to see whether they are the same thing or not. This here is just checking whether they are pointing to the same they're pointing to the same array object. Um, so this would not work. Instead, what you have to do is when you're comparing arrays, is that you have to use a special operator, or you have to go through each individual element and compare each individual element. So if you don't have a special method or operator to do the comparison, then what you do instead is that you go through each individual element. So here you can see that we're first checking the length to make sure that they're the same size. If they're not the same size, then obviously they're not the same, they're not equivalent. Um, but if they are the same size, then we check each individual element. And as soon as the first element that is not the same, then we know that they're not the same and we can exit the comparison. But there's no sense to continue the while loop here. As soon as they're false, you can actually exit out of this. Let's say if this was made into a function, you can immediately exit here and you know that they are not the same or they are different. There's other kind of useful operators. Here, what you're doing here, or some very useful operations on arrays that you're trying to figure out what is the highest value data element or numerical element in this array. And this here is similar for finding the lowest. And so if the elements in the array are not sorted and you have to go through each one individually, this is the way that you do it. These are other kind of useful array operations, getting the sum. And we kind of did this recently on a previous assignment of the sum and doing the averages. And this is the way that you would do that kind of operation. And here, this is the way that keep in mind that if you dynamically allocate the size of the array, and then you need to keep track of how many elements that you allocated, and then you by default they're all going to be set to 0, as I mentioned before, but you may want to interactively ask the users to enter the number, and then you set or initialize the value from the keyboard input. These are ways that you can then save the contents of an array to a file. So you can just have an array of integers here. You can use the print writer, and then you can create a loop and then print the values of that numbers or those values to the output file that you initialize here. So doing it here like this will also initialize the print writer in the try, and that will also help you to close the print writer once this loop is done. So this is reading the contents of a file into an array. Here we've done something similar where we opened up a file on the computer and then went through each one at a time, and then and then set some array or variable to contain the values, and then we increment through one at a time. And here, this is assuming that we know how many elements are in this particular code, assumes that the size or number of data elements in the file is a fixed size. Here, this is a way to return an array reference. So if you're dealing with arrays of something, you can return it as a data type in your function and then return it like this.